All right, everybody, welcome back for another deep dive.
Yeah, welcome back.
So today, we are going super tiny.
That's right.
We are talking about metallurgy advancements,
Yeah.
but like on a microscopic level.
Literally.
Yeah, that'll be
Microscopic.
fun, I think.
Yeah, absolutely.
And, I think you know a lot about this stuff, so I'm excited to dive in.
Yeah, so this is a really exciting area, and it's all about how we can manipulate and understand materials at the atomic level.
Okay, so let's start with I guess the seeing part,
Yeah.
right? So we're talking about things that are billions of times smaller than a grain of sand.
Mhm.
It's kind of hard to wrap your head around, but these microscopy techniques are pretty amazing.
Yeah, they're incredible. Like electron microscopy, for example.
Yeah, how does?
It's like instead of using light, we're using a beam of electrons to illuminate a sample, and that lets us see details that are just way too small for a normal microscope.
So you could actually see the individual atoms.
Yeah, pretty much. Imagine like zooming in on the surface of a metal and you can see all the individual atoms arranged in their specific patterns. It's really amazing.
So it's one thing to see them, but what does that do for us? How does seeing these tiny atoms actually help?
Well, think of it like this. By seeing the arrangement of atoms, we're basically getting the blueprint for how that material is going to behave right.
Right.
So we can use that knowledge to manipulate its properties, like its strength, flexibility, or melting point, for instance.
Oh, okay.
So like if you wanted to make an alloy that was stronger or more flexible, you could add in just a tiny amount of a specific element, and that would actually change the atomic arrangement and therefore the properties of the material.
Wow.
It's like tweaking a recipe.
Okay.
You know, you add a little bit of this, a little bit of that, and you get the perfect texture and flavor you're looking for.
So we're not just observing anymore. We're designing materials at the most fundamental level.
Exactly. And there's another technique called X-ray diffraction. Now, this one's like taking a fingerprint of a material's internal structure.
What?
Yeah, so by analyzing how X-rays scatter off the atoms in the material, we can figure out exactly how they're arranged and how they're bonded to each other. And that helps us understand why some metals are strong, some are brittle, some conduct electricity better than others. You know, all these different properties come down to that atomic arrangement.
So just by seeing these different structures, we can figure out oh, this is why this material is good for building a bridge.
Yeah.
Or this is why this material is good for whatever.
That's right. And it allows us to then design alloys for very specific purposes.
Okay.
Like you could create a lightweight but super strong alloy for airplanes, or you could design a really durable material for a medical implant.
Oh, wow. So it's like custom designed alloys for whatever we need.
Exactly.
That's pretty cool.
It is, yeah.
Okay, so now we've talked about analyzing these metals and seeing them at this super small scale. But what about manipulating them? What about changing their surfaces to make them even more awesome?
Yeah, that's where advanced coatings and surface treatments come in.
Okay.
And this is where things get really, really interesting.
This is what I was excited to talk about.
Yeah, I mean, imagine giving a metal a superhero suit, right? Something that protects it from extreme heat, corrosion, wear and tear, all that stuff.
Okay, so when I was reading about this, I thought it was like sci-fi.
Yeah.
But you're telling me this is real.
Oh, it's absolutely real. And it's being used in all sorts of industries right now.
Okay.
So these coatings, they act like a barrier between the metal and the environment it's in.
Right.
Like, for example, in jet engines, the turbine blades have to withstand incredible temperatures, right?
Right.
So they're coated with these special ceramics that protect them from the heat. And that allows the engines to be way more efficient and powerful.
Okay, so this is literally how we can make jet engines work.
Absolutely.
That's amazing.
Yeah, pretty cool. And then you've got ships battling saltwater corrosion all the time, right?
Yeah.
So they use advanced coatings to protect the hull, and that extends the lifespan of the ship, and it reduces maintenance costs.
Okay.
And it's not just huge structures like that. Even everyday things like nonstick cookware and rust-proof car paint.
Oh, right. Yeah.
They rely on these principles, too.
So these advancements that seem so futuristic are actually already impacting us every day.
Absolutely. I mean, they're all around us.
Wow, that's pretty cool.
Yeah.
So what's next? What are researchers working on now?
Well, right now they're developing coatings that can withstand even more extreme environments, you know, like super high pressures or temperatures or things that are very corrosive.
Right.
But they're also working on coatings with totally unique properties, like self-healing abilities.
Self-healing, what does that mean?
Yeah, so if there's a scratch or a crack in the coating, it can actually repair itself.
What?
Yeah, it's pretty amazing. And they're also working on coatings that can repel dirt and water.
Wow. So like you spill something on your shirt and it just rolls right off.
Exactly like the lotus effect.
That's amazing.
It's really cool.
So I guess like the main takeaway here is that metallurgy is not just this boring old science.
Absolutely not.
It's like it's super dynamic and it's constantly changing
Yeah, it's constantly pushing the boundaries of what's possible with materials.
and it's impacting us right now even if we don't realize it.
Exactly.
Okay. Well, do you have a final thought that you want to leave our listeners with?
Yeah, I would say just think about this. As we keep unlocking the secrets of materials at the atomic level,
Mm-hmm.
what other groundbreaking innovations are going to come out of that?
Yeah.
Will we see 3D printed metal organs, buildings that can withstand earthquakes easily,
Oh,
spaceships that can travel to other stars? I mean, the possibilities are really endless.
wow. Those are some really big thoughts.
It is, yeah.
I like it. Well, thank you so much for
Of course.
diving in with us today.
Yeah, happy to be here.
And for everybody listening out there, stay curious and keep exploring.
Definitely.
We'll catch you in our next deep dive.
Later.
Bye.